So angles are openings, right? How wide the opening is. If it's open really wide, it's a bigger angle, right? The bigger the opening, the bigger the angle. Phones, put away. Chromebooks, clamshell, please. Clamshell them. Okay. So it doesn't matter how big this door is. It doesn't matter if it's a door like this or if it's a door that's 100 feet high. Angles don't measure the size of the door. They measure the opening, how open it is, right? That's what angles measure. So the types of angles. Acute angle, less than 90. Right angle is exactly 90. Obtuse angle means bigger than 90 but less than 180. A straight angle is 180. Reflex angle is more than 180. And then a full rotation is 360 because it's a circle, makes a circle. Circle has 360 degrees. That's why it's full rotation. Okay. Next thing, we have two types of angles, positive angles and negative angles. What makes them positive? What makes them negative? Direction. Direction makes them positive. So you can see this guy is positive because it's opening up. It's opening up. So anything that opens up this way is a positive angle. Anything that opens up this way is a negative angle. So it just depends on which way it opens. Okay? So down here, I put some examples of positive and negative. So the top three are positive angles because they open up. The bottom three are negative because they open down. That's the difference. Okay? That's the difference between them. Okay? Radians. So the other thing we're talking about today is radians. Radians and degrees are the same thing. It's a conversion thing, right? It's like money. We use US dollars. Other countries use euros. Other countries use pounds. Other countries use whatever they use, right? It's the same amount though, right? It's the same amount. It's just a conversion, right? It's kind of like degrees in Fahrenheit. In this country, we use Fahrenheit. It's 80 degrees Fahrenheit outside. It's, right now it's 69 degrees Fahrenheit outside. Every other country in the world doesn't use Fahrenheit. They use Celsius. It's a conversion thing, right? It's the same thing with degrees and radians. They're the same, but there's a conversion. So we're going to be converting them back and forth. Okay? It's not hard. It's just something we got to do. All right. Okay, so let's go to the back side. Let's go to the back. Reference angles. Reference angles. So a reference angle is always an acute angle. It's always going to be less than 90. Okay? It's an angle that makes, so it's the acute angle that the given angle makes with the x-axis. So it always goes back to the x-axis. So I made it kind of easy. So they're going to ask you what's the reference angle. So it depends on which quadrant you're in, right? There's 4 quadrants to a graph. Top right is quadrant 1. Top left is quadrant 2. Quadrant 3, quadrant 4. So if you're in quadrant 1, I put a little cheat sheet here. It stays the same because every angle in quadrant 1 is less than 90. It goes from 0 to 90. Okay? If it's 90, it's not actually in a quadrant. It's kind of in between. So anything from 0 to 89 is in quadrant 1. And then from 91 to 179 is in quadrant 2. Then from 181 to 269 is in quadrant 3. And then 271 to 359 is in quadrant 4. Okay? So the first thing to do is which quadrant is it in? And then you're going to use my little cheat sheet here. Subtract, 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 or it just stays the same. Okay? So let's do the first one. Let's do number 1. 220 degrees. So first thing we got to do is figure out which quadrant is it going to be in. 1, 2, 3, or 4. Okay? So starts at 0. It's positive, right? So we're going to go up. We're going to go this way. So if it's positive, it's going to go up. It's bigger than 90, bigger than 180, smaller than 270, right? So we got to back up. So it's going to be somewhere in quadrant 3. Somewhere in quadrant 3, because it's in between 180 and 270. Okay? Quad 3. Okay? That's the first thing. Second thing, use a little cheat sheet here. Since it's in quadrant 3, we're going to take the angle and minus it from 180 degrees. So the angle is 220. So 220 minus 180 is 40 degrees. So the reference angle is 40 degrees. Okay? Find the reference angle for negative 156. Negative means we start the other way. Negative 90, negative 180, negative 270, negative 360. So negative 156 is going to be bigger than negative 90 or smaller than negative 90, but not the negative 180. So it's going to be in this quadrant again. It's going to be in quadrant 3. Quadrant 3 again. Well, quadrant 3 says take the angle and minus it from 180. The difference here is it's negative. So I'm going to take the angle, but I'm going to minus it not from 180. I'm going to minus it from negative 180 because I'm on the negative track, right? I'm on the negative track. When I'm going this way, I use the dark, the yellow, or the orangish color. I don't use the green. The green, I go this way. So I'm going to minus it from negative 180. So minus a negative makes a positive. So negative 156 plus 180, 24. So the reference angle is 24 degrees. Okay. Number 3. Which quadrant is 18 degrees in? 1, 2, 3, or 4? It's in 1, yeah. It's positive, so I go up, start at 0, 90. It's smaller than 90. So it's going to be in quadrant 1. Okay, so quadrant 1 says you don't have to do any subtraction or adding. You just, the same angle. So it's 18 degrees. So the reference angle for 18 degrees is 18 degrees. Okay. The last thing we're going to do, today we're going to end pretty early because it's not a lot, is converting from degrees to radians and vice versa. Okay. So how do we convert from degrees to radians? Well, if you want to know radians, if your question asks about radians, you're going to use the top formula. If your question asks about degrees, you're going to use the bottom formula. So it just depends on what they're asking for. Okay? So let's go to example number 4. So is this question asking for radians or is it asking for degrees? Radians. So we're going to use the top formula. Okay? So let's set it up. The top formula says radians equals, then it says parentheses, pi over 180 degrees times the degrees. I know degrees for this one, it's 80. So that's where 80 is going to go. Degrees. So I need to multiply. The fraction times 80. How do I multiply a fraction times a not fraction, times a non-fraction?
You have to make it a fraction.
Make it a fraction. Cross multiply. So when we say cross multiply, we can mean two things, right? Diagonal or straight across. Which one are we going to do for this one? Diagonal, like we've done before, or straight across? So when we do diagonal, what's always been in the middle? Equal sign. We've always had an equal sign in the middle, right? This one we don't have an equal sign in the middle. So this is where we're going to go straight across. Straight across. Okay? So what is that going to look like? It's going to look like this. On top, I have 80 degrees times pi. It's just two lines with a little swirly thing. Two vertical lines and then a little wavy. On bottom, I'm just going to get 180 degrees because times 1 is just itself. Last thing, reduce. Degrees divided by degrees. Degrees goes away, so I don't need degrees anymore. 80 and 180. I got to reduce 80 and 180. I think 20 definitely goes in. I'm not sure if 30 or 40 goes in. The easiest way to do it is just use your calculator. So 80 over 180.
Did we just forget about pi for some reason?
For right now, we are. We'll come back to it. It's still there. But I want to reduce this guy. So 80 over 180 reduces to 4/9. Okay, so I'm going to go back and put 4/9. Great question. What happened to the pi? Pi's still there. So was pi on top or pi on bottom?
So I guess it doesn't matter if you multiply after you divide it by 180, right?
So I divided both of these guys by, looks like 20. So this became a 4, that became a 9. Pi stays because I can't cancel out pi. The only time I can cancel out pi is when there's a pi on the bottom as well. There's not, so it stays. Most of the time, when you're using the top formula, you'll have a radians left or a pi left over. Most of the time, not all the time, but most of the time. Okay, let's do the second one. I'm still looking for radians, so I'm still going to use the first formula I just used. Radians equals pi over 180 times degrees, 125 degrees. Okay. Turn 125 into a fraction. There's no equal sign in the middle, so I'm going to go straight across. So when I go straight across, look, I'm not going to quite multiply yet. I'm going to get 125 degrees times pi, and then 180 degrees because it's just times 1, right? Now reduce. Degrees go away. And then I have to find the biggest number. I think 5 or, no, not 25. I think 5 is the biggest thing that goes into both. So let's see, 125. Yeah, 5 is the biggest thing. So divide them both by 5, and you get 25 over 36. So this becomes a 25, and this becomes a 36. So 25 over 36, and then pi stays on top with the 25. So 125 degrees as radians is 25 pi over 36. 25 pi over 36 and 125 degrees are exactly the same thing. 4 pi over 9 is the same thing as 80 degrees. They're exactly the same thing. Okay. All right, let's go to the next one. Number 5. So number 5, do we want degrees or do we want radians? What is this asking for? Degrees. So we're going to use the bottom formula now. The bottom formula said degrees equals, now it's 180 is on top, pi is on the bottom now. That's the only difference. Radians is going to go next to it. So they told me it's 13 pi over 12 radians. That's what they told me. This one is already a fraction, so I don't have to make it a fraction, right? So I'm going to multiply straight across, but I'm not going to multiply yet because 180 times 13 is something big, and I'm not going to do that yet. So watch what I do. So I got 180 degrees times 13 times pi. And on bottom, I have 12 times pi. So I know it's multiplication. I just haven't crunched the numbers yet. There's a reason why, because I'm going to have to reduce. So it's all multiplication on top and all multiplication on bottom, right? So I can cancel things out. So what can I cancel out first? Pi's. Pi's go away. Pi divided by pi is 1. Now I have a 12 down here and a 180 and a 13. I know 12 doesn't go into 13 evenly, but 12 I think goes into 180. Let's see. If I divide them both by 12, let's see, 180 divided by 12. 15 it does. So I'm going to go divide both of them by 12. This guy by 12, that guy by 12. So this guy becomes a 15, this guy becomes a 1. Just reducing the fraction. And sorry, degrees is still there. Degrees is still there. That hasn't canceled out. So on top, I got 15 degrees times 13 times 1. On bottom, I have 1 times 1. Okay, so let's go to the calculator. 15 times 13, 195 degrees. The 1 you don't need on the bottom because anytime a 1's on the bottom, you don't need it. So 13 pi over 12 is the same as 195 degrees. And that would be in quadrant 3. Didn't ask you, but it's good to know. All right, let's try number 6. Same equation, same formula. Multiply straight across. I get 180 degrees times 2 times pi, and then I get 3 times pi on the bottom. Okay. So let's reduce. I can divide. Since it's all multiplication on top and all multiplication on bottom, I can reduce. Pi's go away. 3 goes into 180. 3 goes into 3 once. 3 goes into 180 60 times, so that's going to change to 60 degrees. So on top, I have 60 degrees times 2. That's 120 degrees. On bottom, I just have 1. You're done. So 2 pi over 3, or 2/3 pi, is the same thing as 120 degrees. That would be in quadrant 2. Okay. Okay, last one. Last one. Here's the question. Am I looking for radians on this one, or am I looking for degrees on this one?
Is there ever a possibility where the bottom is not a 1? Like it could be another number?
The bottom. Maybe. Yeah. Let's do this one, and then I think this one might answer your question. Degrees, right? I'm looking for degrees. Okay, so we got degrees equals 180 degrees over pi times, oops, that's in parentheses. What is the radians going to be here? What's the radians part going to be here? -3. Yeah, -3. It's negative. We haven't seen a negative one yet. That's okay. Doesn't have a pi. It's okay. You just put -3, and then we're going to put over 1, right? Because -3 isn't a fraction. Okay. Multiply straight across. I get 180 degrees times -3. And on the bottom, I just get 1 times pi, which is just pi. Is there anything I can cancel out or reduce? Yeah, right? Because pi, if pi was on top, I could cancel them out, but there's no pi on top. So the only thing I could do is multiply, right? That's what I'm going to do. The only thing to do is multiply. So I got 180 times -3. -540. So here's one with on the bottom. So, oops, this is still degrees, sorry. It's still degrees. Normally I would stop here and say that's my answer, but it says round. Round means keep going. Don't leave as a fraction. If it says round, that's when you got to divide. If it didn't say round, if this part was not here, you would leave that as your answer and you'd be done. But because it says round, that means they want us to divide. So we're going to divide. So -540 divided by pi. Pi button, there's always a pi button. On this calculator, it's right above the tangent button. And it says round to the 10th. -171.8. So the 8 can stay or go up. And it's going to go up 1 because of the other 8. So it's going to be -171.9. -171.9. And it's still degrees because the degrees is still there. Okay. All right. All right. Let's see. So tape this one in.